So this is a video on excavation works because someone basically asked me what do you know about excavations. So I'm gonna just do a video on that, and then it's also information for the YouTubers. And then this is just somebody saying don't forget to multiply by G to get the force. So always when you multiply your mass with gravity, force equals M times A, mass times acceleration, and force equals M times G as well, mass times gravity. For those that know that formula, I think that's Newton's law. The one that basically states F equals M times A. And then you get the one that states M equals F times G. Force is always in Newton or in kilonewtons. One of the two. Newtons, kilonewtons. But this is mass times acceleration, so this is I think Newton meter seconds. Because usually this is the system that we use for a car. So mass times acceleration will give you the force in a certain direction. Let's say that car is driving, and that car is a type of mass, but it's accelerating at a certain speed, and there's a force in a certain direction if it's going in that way, and it's a force in that direction. Same with mass times gravity. If there's a brick with a certain kilogram, somewhere on a building, and it falls off the building, and it's accelerating at a force, and that's the gravity law, mass times gravity. Mass times gravity, and that's how you get the force. The forces. Okay, so let's start. Before foundations can be laid, a trench of the required depth and width needs to be excavated. On small contracts, this is still carried out by hand, but on large works it is often more economical to use some form of mechanical excavator. So what they just say is that on small contracts, excavations can still be carried out by hand because then it's not that difficult, and there's not a lot of trenches. But whenever you deal with a big project, you should consider mechanical excavators, because then it's just more economical. And here we can see that they say A is a representation of digging a trench by hand, and B using an excavator. Okay, so doing excavation by hand leads itself to the applicatic. I don't know if that's a word. Leads to the applicatic. It's probably leads to the application of labor enhanced construction, which is seen as a form of employment creation. You will read more about labor enhanced construction methods in Unit 12. So it's in the coming chapters, the coming units. Doing work mechanically is time saving but requires more capital investment. Okay, so timbering is basically just using timber to box out your trenches. So timbering refers to the temporary supports for the sides of excavation, temporary supports for the sides of excavations. It is also called planking, strutting, and shoring. The supports are used to prevent the sides collapsing, prevent the inflow of loose material, prevent damage of the adjoining property, so the property next to the excavation, keep the excavation open by acting as a retaining wall to the side of the trench, and most importantly, keep the workers in the trench safe from collapsing soil. So timbering is not needed for trenches less than 1.5 meters, 1.5 meters deep, if the soil is stable enough to support itself. However, if there is enough space around the proposed trench, the sides can be flattened. It can be flattened out to prevent them from collapsing. It is common practice for the slope on either side of the trench to have a 1:4 gradient. So that's what they mean. They say if there's enough space around the proposed trench. So if you have a site and you're busy digging trenches and there's enough space next to the trench, then the sides can be flatted. Like you can flat it maybe this way and that way with a slope of 1:4. So for every 1 meter rise, you have a 4 meter span. So you can span up to 4 meters every 1 meter that you go up. And they also say that it's common practice for the slope on either sides of the trench to have a 1:4 degrees, so on either sides. And currently this is an unprotected trench. Okay, so basically this is just an activity, but it's stating that you should use a 20 centimeter in your horizontal plane, 20 centimeter in your horizontal plane, and then let's say from there to there 20 centimeters, and then 5 centimeters from there to there in your vertical plane, and then you should just join the two lines to two end points, and then you will get the slope. That's basically what this activity is saying. But then you should use a ruler to make out a slope of 1:4 in scale 1:50. Make a mark on an A4 page 20 centimeters along the horizontal axis and 55 centimeters along the vertical axis. Connect these two marks with a straight line. A similar exercise is done on site using timber to indicate the slope of the sides of the trench. So I'm not going to do that activity, but it's basically almost the same as this. Is 5 centimeters in vertical, and then 20 centimeters horizontally, and then you just join the 2 points, and then you get the slope of whatever. So in this case it was 5 on the y and 20 on the x, so the slope is 1:4. That's how they got to 1:4. So the contractor or a qualified engineer usually does the design of the timbering. The type and amount of timbering needed depends on the nature of the soil, which means if it's hard, firm, loose, sandy, clay, etc. The depth of excavation, the presence of groundwater. The proximity of buildings, so the nearness of buildings, how close the buildings are to the excavation, weather conditions, and the duration of the operation. Like how long will it be taking place, how long will the trenches be open, all of that. Okay, so basic timbering, excavation terminology. Polling board are 1.5 meters in length and vary in cross section from 175 times 38 millimeters to 225 times 50 millimeters. They are placed vertically and support the soil at the sides of the excavation. So basically what I mean with that is if we look at this sketch, what you can see, this is a polling board. This one here, polling board, that side and that side, the orange. So usually they're 1 meters to 1.5 meters vertically, and then the cross section, which means the cross section can be 38 millimeters by 75, so 38 by 75, or 50 by 225 millimeters. And then you also have wallings. So wallings are longitudinal members, so horizontal members running the length of the trench and are used to support the polling boards. So in this case, these are the wallers or wallings, the ones in blue, and they are there to support your polling board. Like we said, the polling boards are the vertical ones, the orange ones, and your wallers, they are just supporting the vertical sheets, the polling board. And usually the conditions here is this one you use for loose soil, and this one you use when you have hard soil. But I'm assuming hard soil, the conditions can be wet as well, like when it's very rocky but wet, like near a river. But you can see that the soil is very hard, This is if you have loose soil, and then you get dry soil. Maybe it's hard soil but maybe dry, or it's loose soil but it's also dry soil. Like it's loose soil but the conditions is also dry. I'm assuming, or dry soil can be, the conditions is stable, it's hard soil but it's dry. For this it can be wet as well. The soil can be wet, it doesn't matter. Like according to your engineering design, the soil is maybe geographical studies, maybe the soil is hard, then you don't need to, even if it's a wet condition, and you don't need to use a lot of polling boards. But in this case, if it's dry soil but the soil conditions due to your studies isn't like stable, then you have to put like polling boards maybe every second phase. Let's say this is a phase, first phase, second phase, or you open, or like when you have a board, you leave a space open in your second phase, leave a space open in your second phase, then you put a polling board. That's what I'm assuming. So let's just see what they see as a strut. So in this case, struts are square timber, 100 by 100 millimeters or 150 by 150 millimeters, that are generally used to support the wallings. They are placed approximately 2 meters center to center, which means 2 meters, 2 meters, 2 meters, if the trench is running in that way, center to center, to allow for adequate working space between them, like so that your trench workers, the people in the trench, or maybe the excavator doesn't, make contact. So every 2 meters you have like if the trench continued, if your trench had to continue in this direction, then you would have had one, maybe that's it, And you would have had one sitting here as well. So the distance from here to there would have been 2 meters. So every 2 meters you would have had one. That was that board. So it would have been like if this was another strut, and it would have been 2 meters apart from each other from here to here, if the trench had to continue in that direction. So basically the strut, the one that I just went over now, that says that it's 100 by 100 millimeter or 150 by 150, is that square, piece, the yellow one. It's the yellow one, sitting there. We call that a strut. That's the strut there, the yellow piece here. So it is basically, causing a force onto your wallings, onto the blue sections. So it's basically just preventing the trench from collapsing. So that's the one supporting. This is the one that's supposed to be, depending on your conditions also, you can change the thickness of the cross section for your strut, because that's also going to increase your force. Your force is going out, like keeping the wall intact, or preventing the trench from collapsing, if you want to put it that way. So sheetings, they say sheetings consists of horizontal boards abutting, joining trenches, or joining, like abutting just means being next to each other, abutting one another. So joining one another to provide a continuous barrier, a blockage when excavating in loose soil. So that's basically what you see here, your vertical sheetings, because that's what they said. They said sheetings. So the main word is sheetings. This is just vertical sheetings. That's just to prevent loose soil from falling into the trench if you have loose soil. Now they say runners. Because I'm not sure if you can say a runner is a polling board, but they say runners are polling boards. So the runners are the polling boards. Runners are polling boards, but it's the same thing, in continuous formation. So runners are just polling boards, but in continuous formation. So in this case, this is runners. Like this is just normal polling boards if they're not in continuous. And the same as when you place one, skip one, place one, skip one. We just call it polling boards. But the moment we put them continuously, like running next to each other, we call them runners. It's just another term for polling boards next to each other in continuous formation with tapered base edges. A common size is 225 by 50 millimeters. They are suitable for use in loose or water-lodged soils. So they are suitable for using. Usually we use them when we have loose soil or when there's water-lodged soils. like we said, loose soil. So puncheons. I don't know if I'm pronouncing it right. Puncheons are vertical supports that are wedged between the wallings at or near the ends of struts. They are necessary in deep excavations to prevent the wallings from dropping off. So we know that this is your wallings. So for deep excavations, that's when we're going to use them. They are just like vertical supports, sitting between your wallings. Let me just see if I can move it this way. There you have a puncheon. It's this one here, vertically. So they basically, causing a force in that direction, in this direction, so that your top walling doesn't fall down. Or let's say there's a load, that's placed on that walling, that it doesn't fall down. And in a way, it's also keeping your strut, in place, extra support. But it's the main reason is so that the walling doesn't fall down. Yeah, then that's it. They are necessary in deep excavations to prevent the wallings from dropping off. So we'll continue on the next video, the next part 2. We will continue on trench excavation safety or safeties. So we'll do that in the next video.